I'm glad I'm behind Oded because he touched on some of the things that I'll be talking about, and especially in terms of the future, or what he calls the 5 minutes or 10 minutes or a year or 2 years from now, from an automotive perspective. And I'll go a little bit more into the details of how to make it happen. We're based in Herzliya, not too far away from here. And we're part of a global R&D that GM has with its headquarters in Detroit, in Warren, Detroit. Our second largest center is here in Israel, and the third one is in China. The kind of work we do focuses primarily on automated driving and autonomous driving. And we have groups that deal with controls and robotics, people that work on wireless, how to make cars communicate with one another, smart sensing, visions, radar, and all the bit, and user experience, which is the group that I work in, which is related to all of us here, which traditionally worked on infotainment systems, radios, heating systems, and all the features you see in the cockpit, but now is more focused on this problem of autonomous driving. The world that we'll see not too far away, and it will start in primarily high-density urban areas, is a world where we're driving in cars that are autonomous. In this vision, we are actually engaging with a rather complicated system. It is not your regular car that you drive today. And for the most case, we will not provide training. Now, these are not airline pilots, and so they don't get training on how to use these systems. At the same time, we see that drivers today are not interested in the act of driving. They're interested in the act of communicating. And if you see people drive today from the outside, you see about 50% are engaged in some form of communication. So driving becomes secondary. In this world of autonomy, one of the sheer biggest problems that we see is the shift from automated into autonomous. In automated, such as in an airline cockpit, the automation is either the autopilot is on and the pilot can sit back and relax, or vice versa. In autonomy, it's a different story. Here we're talking about teamwork. And this is a citation from Dave Woods and Jeff Bradshaw, rather classical work, where they talk about that we need a leap forward. We need a breakthrough in how to make that teamwork happen. It's easy to talk about. It's very complicated to do. And this is what we're set out to do in the context of what I'll show you today. Here is an HVAC system. That's the lingo in our industry. It's a heating, venting, and air conditioning system. It belongs to a car called Volt, which is an electrical car that we sell in the US. And as you can see, kind of a classical system, delivery modes, and fan, eco, which are, because it's electric, it needs to be more efficient in terms of air conditioning. But what we find in consistent user surveys is that people are not familiar with these systems, have trouble operating them. And for the most part, they drive in a suboptimal state, meaning that they are not using the system as they should, and they get frustrated. To address this problem, we looked at how can we think about an autonomous system that does help you manage your heating system. And what we did is we wanted to listen how people would actually engage with an autonomous system in a very, very small system, this HVAC system. So what we did is we took 11 participants and took them on a drive from our location in Herzliya to Yakum and back, and let them experience what it is to drive in a car where they have an experimenter who is actually there as their quasi-autonomous system. So we told them, you can talk to him, you can make body languages to him, you can make comments to him. He is your assistant. Tell us how you would like to operate the system if we're not talking about a user experience, a pure human interaction. And we logged this. And what we found is that the way people communicate with another, excuse me? No, this is actually, I think this is participant number 5. So this is basically a run of her drive. And in her drive, we get into a situation where the car is stuffy, it's a little bit stinky, and she needs to begin to drive and figure out how to make the car feel better. Situation where she gets into a hot car. Now she needs to get back on the road, and now she's getting back on the road at the same time trying to reduce the temperature in the car. You'll see a situation where the experimenter is actually sensitive to the participant and actually figure out what does too much means. So if we look at a voice recognition system, too much, what does that mean? But if you look at the history of the events and maybe some gesture, you'll know what he did. And what you see here actually is the utterances, and these are the actual configurations that he's making in response to these utterances. This is the continuation of the same drive, and she's saying, cold on my arms. And if you were a machine, you'd say, oh, cold, that means to reduce temperature. But look, he's not reducing the temperature at all. He's changing the fan setting, because he's understanding what she actually needs and not necessarily what she asks for. And that's a big distinction. Here's another one, less cold, just a bit. And what he's doing is changing a fan level and keeping the temperature as is. From all these 11 trials, we began to hear something very different than we usually accustomed to when we look at interaction between humans and machines. So if we usually think about humans and machines in the context of a computer, a screen, in 1996, Clifford Nass and Byron Reeves talked about the fact that we actually humanize the media. That we talk to a computer, we curse the computer, we get upset about the computer, but it's only a machine. So they talked about this concept. We feel that actually we need to go further into what we call object relation, which is a concept that Melanie Klein came up in 1939. This is from psychoanalysis. She talks about the relationship, and that's object relation between an infant and his or her mother. And what we've seen in the way that we've done our runs, that's exactly the interaction that existed there. It's about sensitivity, the ability to understand what the driver actually wants, even though they're not saying what they are saying, which is equivalent to a baby crying and a mother being able to understand what the baby needs. Is it diaper change or is it food? And notions of holding, which means how to deal with frustration, and containment, which is how to deal with progressive growth. And these ideas came out of Wilfred Bion and Donald Winnicott, which are in the same role, but they, of course, were made for human and human therapist interaction. We took them in the context of a machine. Before I go to the actual implementation, I just want to say that today what we give drivers is a bunch of buttons, temperature settings, mode settings, which they don't really care about. But that's what we do. We said, okay, let's take these and see if we can go higher on the level of abstraction, all the way up to a point where we have a complete autonomous system that needs no human input, or lower where we say, just tell us, are you comfortable or you're not comfortable, and we'll figure out what to do. Or perhaps just cool me, heat me, softer on the fan or on what I'm getting on my face, or stronger. There's very different levels of abstraction here. We've implemented this in an AI system, and I'll show you a little bit how it works and how the concept from Melanie Klein's object relations were actually embedded in code. So the idea is that a driver gets into the car and shouts, it's stinky, it's stifling here. I can't breathe. We understand that as being, given that we know that the air quality is low, and we actually understand the word stifling, and we know that he made it in a very loud voice, that he's angry. From a user model function and a semantic dictionary, we are trying to understand what actually is the precursor. What does he want? And out of that, we understand that he wants actually fresh air, and he wants it fast, now. We take what we know about the actual state of the system, and we take what we know about the available states of the system, and we come up with the goal recognizer that says what actually we need is fresh air at fan 50%. Nothing about the states or temperatures of the actual system, but that's what the user or the driver wants. From that, we translate it into the actual system, which will be air source out, fan speed 4, could be 5 for another car, mode comfort, and then we execute it. That's our cycle. Based on this model and based on this abstraction of that Volt car, we came up with a system that, or an interface to the driver that has 4 settings: softer, stronger, hotter, colder. I'm comfortable, uncomfortable. And also, you have to understand when they say uncomfortable, that means the machine now needs to do some kind of a restart, understanding that the path it went through is not a good one. And we implemented that system, tested it, and then wanted to compare it to existing systems. So what was our experimental manipulation? The same human agent that we had before, somebody sitting in the car, listening to what you say, and since he's an expert on these systems, can actually configure it best to suit your needs. The software agent that I talked about, and the actual existing device that exists today in the car, all these were done through speech. This is actually an experimental design. In our cadre, we had more males than females, and we wanted to see, was there a male-female effect? Because in the literature and the anecdote, people say, oh, you know, women are like this, men like that. We wanted to test that. And just as a kind of a heads up, we didn't find any differences, so forget about that story. We did the same route from Herzliya to Yakub and back, using the same car, and I'd like to share with you some of the results. In terms of utterances by interaction type, so we have the human agent, which is kind of the most superior interface, the software, and the manual. We see a difference in the sense that the number of utterances in the manual is very high. So you could very quickly get to your optimal setting here, there, and higher there. Just in terms of what I'm using, these are box plots. So this represents 50% of the data, 95, 5, and these are outliers. In terms of frustration, we measured frustration, and you can see that the manual was highly frustrated, and this was, of course, not frustrating, and this was in the middle. In terms of task load index, which is what is the cognitive capacity that's actually being devoted for this task, and don't forget that this is a secondary task, but because the primary task is the driving, we see the same pattern. Human agent being far more superior, software agents about the same as the manual. Overall experience. And here we see that the human agent was better, software agent less, a little bit worse than the human agent, but look at the fact where 50% of the counts reside. It's a much smaller pack, which gives us kind of a good feedback, and the manual being not so good in terms of experience. We have more and more data, but it pretty much looks like this. So on this, I'd like to conclude and talk about the main problem that we're trying to address, which is how do people interact with an autonomous system in situations where they don't know that system very well. And for a large extent, they don't really care about that system. The current state of affairs in automation and also human-machine interactions is that we don't have a theoretical framework. Yes, we have some principles from Wickens, we have Gestalt principle, we know about display control compatibility, but we don't have a guiding theory of how to do it right. And we with respect to automation, because we didn't have that theory, we made a lot of mistakes and we failed and we killed people because of that. What we propose here is to use a psychoanalytical theory that we feel can be actually used in situations where peoples and machines need to interact in a way that takes care of this mother-infant relationship. That it's basically the same relationship that goes on in these situations, especially in a comfort control system. Now, the extensions that we made, that the object or the phenomenology that the subject or the user is actually experiencing is not a human. It's not his mom. And it's not somebody that you care about. It's a machine. And that's a big extension, but if we think about object relation, it's not a bad extension because for the infant, he doesn't know the mom. All he knows is a breast. All he knows is a certain face. He doesn't understand what goes in there. And our focus is to try to see how do people interact with this object. What do they expect from the object? And how do they take in the input from this object? And the point is that we get into a steamy car and we're hot and humid and we need to drive. We don't care about the fan settings or the modes or the temperature. We care about, now I feel miserable, I want to be cooler. I've presented here a theoretical framework. We made it computational. We did some drives with it. And we got some initial results. We're now working on a much, much more sophisticated system and trying it out. Finally, I'd like to say that kind of a credo or kind of main thinking is that this teamwork issue is very, very critical, both in terms of human automation and human autonomous interaction in these complex systems, but I think it's also going to migrate very soon into healthcare and eventually into software system. Understanding how to do it right is a big, big question. And what I've shown you is a little insight of how we think it is possible to address it. And all that on end. Thank you.